Hello, in this video we're going to find the rules for resistors in series. We have checked the rules for current and voltage in series connection. How does the current behave in a series connection? Yes, the current is equal among the components of a series circuit. So, if there is a circuit with a battery connected in series with two resistors, R1 and R2, the total current passing through this circuit, I total, is equal to I1, which is the current passing through resistor R1, and equal to I2, which is the current passing through resistor R2. And what about the voltage? Yes, the voltage is additive between the components of a series circuit. For the voltage, let's assume the previous circuit where the battery is connected in series with two resistors R1 and R2. The total voltage, which is the voltage supplied by the battery, is equal to V1, which is the voltage passing through R1, added to V2, which is the voltage passing through R2. So, based on these two fundamental properties, we're going to derive the equation for adding the resistance for series resistors. Recall Ohm's law. Ohm's law tells us that the voltage V is equal to the resistance multiplied by the current. V is equal to Ri. And based on the information that in a series connection the voltages are additive, and assuming that we have a circuit with a battery connected to two resistors in series, then the potential difference of the battery, represented by its voltage, we're going to name it V total, is equal to the voltage across the first resistor added to the voltage across the second resistor. This is because the voltage is additive in a series connection. And now let's replace each voltage using Ohm's law by its expression. V total is equal to R total multiplied by the current. V1 is equal to R1 multiplied by the current, and V2 is equal to R2 multiplied by the current. So let's replace them in the equation. The equation is thus R total multiplied by the current is equal to R1 multiplied by the current plus R2 multiplied by the current. And recall that the current in a series connection is equal. So we can divide by this current. We can divide this equation by I. Therefore, the equation is R total is equal to R1 plus R2. This gives the total resistance of two components in series. This total resistance is equal to the sum of the resistance of each component. Adding more resistors in series increases the total resistance of the circuit. So, the total resistance in series connection is equal to the summation of the resistance of each component. For example, they are 5. So the total resistance is equal to R1 plus R2 plus R3 plus R4 plus R5. By this, the total resistance increases if there are more resistors in series connected in the circuit. Why is this? Because the total potential difference is shared between more resistors. Recall that the voltage in series connection is additive. That's all. Thanks for watching.